Alright guys, I want you to look at your homework spirals open. You had some of these homework problems last night. We did walk through before the drill. Even and odd. Even is describing y-axis symmetry. Odd is describing origin symmetry. We're starting at the very end of homework and working our way backwards. So our goal in even or odd, when testing with even or odd, is we're thinking function notation. Plug in negative x, that's step 1. Simplify f of negative x, then ask ourselves, does it stay the same? If so, even. Let's see, y-axis symmetry. Does it switch the sign? Does it make the whole thing opposite? Then odd. And does it do a little bit of both? Then neither. My neither doesn't fit. So is it the same? Even? Is it opposite? Odd? And is it a little bit of both? Then neither. Now, these ones over here get a little bit complicated as we look at them. So you guys, I want you to peek at them. And in your homework, you already did a couple. Can you check the couple that maybe you did it? Maybe you just wrote down the problem and like try to draw a picture or try to do some sort of attempt to show me that you kind of tried. Or maybe you took me at my word yesterday. I said I would give grace. You didn't even work on the even odd ones. Can you look at those 6 and can you make a quick hypothesis just by eyeballing it as to whether you think it's even or odd or neither? So I'm going to go ahead and give you guys what the right answers are. That doesn't necessarily mean you didn't have a lot of time to try them. I was just trying to see if you guys could eyeball it and make a guess. I guess the phone rang. Do you want 30 extra seconds? Here, 30 extra seconds. Some of you have not even thought about them yet because the phone rang and you were like, huh? Okay. I know, phones on walls is pretty crazy. It's not a thing anymore. How many of you guys have like an actual landline at home? Yep. There you go. Yeah. A few of you, not a lot of you though. It's called a landline because it's not just wireless, it's not just a cell phone or an internet phone. All right, I'm not sure that extra time is really being used productively, so here we go. Here we go. Let's talk about landlines. Landlines are like phones that are hooked into the walls, as opposed to like hands-free or wireless. Hands-free would be that way, but like wireless. Okay, number 71 is even. Number 73 is odd. Number 75 is neither.
I didn't get that.
Wait, we were supposed to be 73.
I was having you guys just now look at all 6 just to make an eyeball. Not in your homework, but just in notes. And you could have been looking at the homework ones you already did. We're going to have an odd, and then we're going to have a neither, and then we're going to have an even. Okay, let's check out what's going on. You guys ready? Which ones were your actual homework ones? Because some of these you already tried.
71 and 75.
I gave you odds of these on purpose so you could check and count chat in the back of the book and see if you remember them.
I mean, I checked on Slater.
Or Slater? What ifs? But coming back, I like that you said checked and didn't just steal. Stealing from Slater's bad. Checking on Slater is a whole other thing, as long as you do it right. Number 71, why is it even? When you plug in a negative x and you do a negative x to the 6th minus 2 times negative x squared plus 3, and you simplify, plug in, then simplify, what happens to the whole shebang because you only have even powers? It stays the same. And if it stays the same, the answer to it isn't even, right? Now, what if, because we're practicing for tomorrow too, and yes, there is, I think, one even odd question on this. What if I was to plug in negative x to number 72? Why is it an odd? What happens if I raise a negative to an odd power?
It stays negative.
Yeah,
It stays negative, but this one also changes the sign, right?
Yeah.
And so couldn't I pull out a negative of the whole shebang and it goes back to the beginning? This is the opposite of the original.
That's tricky.
Hence, odd. If it's the opposite of the original, then it's odd. Now hold on, number 73, wait, okay, hold on. This one's also odd, but maybe for some of you it would be a little bit harder as to why or how. Can I skip to the simplified? simplify, and here's what you would get. You would get f of negative x to equal negative x square root of, the negative goes away. Some people would say opposite, same, neither.
Wrong.
But do you guys see this is technically a negative 1 times?
Yeah.
And I could technically say that this is just 1. There's no addition or subtraction. I'm not doing anything illegal if I just say multiply this first and then that. So technically it is the opposite of the original. 1 negative in the very, very front would multiply to this entire quantity and make it the opposite sign. So this one is odd because of that negative in the very front being multiplied to the whole other multiplication or to the whole other product is making it opposite or odd. Now, why is number 74 neither? It's the first one that would come up against. When I plug in and I simplify, I have a negative x outside and inside. You see the dilemma?
Because if you multiply by -1, it just...
Yeah, that's a negative 1, and I separate. This is not the same as it was to begin with, was it? Or is it? No. So therefore, I have the opposite of not the original, so it's not truly the opposite. It's a little bit of both. Something changes, something stays the same. This is a neither. You do not have to have symmetry. A function does not have to be even or odd. Even odd is a special adjective that is sometimes true, but not always. But you guys told me number 75 was neither also, and that kind of looks like an odd one to me, so why is number 75, another homework problem, also neither? Sorry, what was that coefficient?
4.
Give me the function. It was h of x?
4s.
4s.
Cool. What was the name?
That's
F of x. Okay, sorry, thanks. So if I have plugged in, sorry, that's just the original. If I plug in a negative s, if I maintain the meaning, this would be a square root of negative s cubed. Now, a negative cubed is a negative. Oh, didn't it just make it opposite? Can't I pull that negative out? Can I pull a negative out of a square root?
No.
I've just entirely changed the meaning. I can't pull that negative out and make it the opposite of the whole thing. Yes, under here it'd be negative s cubed. Since I can't pull that out to show the opposite, this is a neither.
Because the 4 stays the same. The -s.
But what's different in number 76 that makes it work?
Oh, it's 2/3 instead.
Is it still 4s?
Yeah, it's 4s, but
And f of x?
2/3.
Yeah. This time when I plug in check, my f of negative x is going to be a cubed root, which says I can have positives, negatives, I don't care. But it doesn't really matter because what happens to that s that's being squared anyway? Sorry, the negative
It
s.
becomes positive.
Same. And since it's the same, what does it become? Or what is it by definition? Even. So if it stays the same after plugging in and simplifying, even. If it flips to become the opposite, then it becomes odd. And if you cannot, like this one, it was illegal to bring the negative out, that's a neither. Or this one, okay, there was a negative out, but this is different, that's a neither also. Okay, that might not perfectly answer every single possible question of any possible function you might see in how to test for even, odd, neither, but at least it gives you a starting point. But if someone does have like a quick clarification that they need to see on any of these ones, the even, odd ones, or on like the property itself, the adjectives themselves, the way to test themselves, now's a good time to ask about even and odd. Okay, the rest of homework, here we go. Let's grade those evens. The rest of homework. Section 1.5, starting with the vocab. Number 2 should have just been the zeros of the function, otherwise known as x-intercepts, right?
Domain?
Number 2 is domain.
Like, can it be domain? Because technically it's not.
It would be a part of the domain, I suppose, because the zeros are x values. Number 6 is odd, talking about f of negative x equaling negative f of x. I could do page width, sorry, it might be a little too zoomed out. Number 20, You had to find the zeros, and it was nasty unless you did grouping. Number 20. Now, you're not going to see something with a cubic polynomial tomorrow. That's just, I'm not going to do that for zeros. But in homework, I gave it to you because it was a grouping problem. You could have pulled out what was in common. There was an x minus 4 that could be pulled out. A difference of squares. Did you guys find all 3 zeros? Plus or minus 3 from the difference of squares and 4 from the other one. Now, we're going to review more factoring. Don't worry. If you're scared of factoring, there'll be a little bit on there tomorrow, but not crazy hard and definitely not a cubic. Number 32. Number 32. Did they give you a graph for number 32? If you look at the graph, you could have seen that the x equals 2 is the separator. If you looked at the graph, you could have seen x equals 2 is the separator between the decreasing portion and the increasing portion. But remember, you're answering it with x intervals. So how left was the decreasing portion? From negative forever, negative infinity, all the way up to 2. And then it started rising after that. The graph started rising after that. Now, number 32, I think I have, oh yeah, it totally has a picture. So you guys could see it falling, decreasing, and then increasing. But that x equals 2 is the separator. We're doing x intervals, so use the x. Yeah, there is no constant because it never went flat. It never went flat. Number 36 is doing a lot of different stuff, yeah? So let's get the picture of 36 and try to figure out what's going on. The nasty thing for 36, which once again is probably nastier than tomorrow, is that it has a vertical asymptote breaking everybody up. So the vertical asymptote, I believe, is at negative 1. Is that what you guys saw? You can kind of tell from the equation if you remember how to do that. So if I'm looking at this, the negative 1 kind of breaks up the graph. And then I also see this negative 2 and this 0. So I see the graph rising here and rising here. Do you guys agree?
Yes.
Okay, so you just have to figure out how to say that. So rising is the same thing as increasing. And I can say from negative forever, that's how far left that rising will start, all the way up until it stops here at negative 2. And it, wait, x, at 0, it starts rising again. Decreasing, see this negative 2? That was when it stopped rising and started falling. So from negative 2, now here's the weird thing. From negative 2 to negative 1, this vertical asymptote cuts the graph. So I have to say from negative 2 to negative 1, it's falling. And then past, you see it?
From negative 1.
Yeah, past negative 1, it's falling also. So we could say from negative 1 to 0. And that's how they got all those separate intervals. It's because they had to split it up at that vertical asymptote and use that as a boundary also, because it kind of like cuts the graph. It kind of cuts the graph. Using x intervals, how left to how right. 52, I think you guys were just graphing it on your calculator and practicing how to find min and max.
Yeah.
But I don't think we've actually done the, well, I know we haven't done the graphing calculator handbook yet. So even though some of the homework is asking you to do stuff on the graphing calculator, I'm not going to test you on that yet. I'm not going to test you on that yet. You're also doing a relative, wait, where's the min? There isn't one because what's going to keep on happening? It's going to keep decreasing, yeah. You guys have for number 60? No more biscuit girl for a second. Number 60?
There's no x-intercept.
It never goes above the axis, so I can't answer the greater than or equal to. It doesn't even hit. Huh? It's less than. It's less than, but it never goes. Oh, you asked this one yesterday, I think, or maybe period 5 or period 4 did. But this one does go above. But it wasn't asking that. It was asking even or odd. So this one's even because it has y-axis symmetry. You could tell from the graph. Or you could tell from plugging in and it stays the same. I think that's, oh, no, yeah, one more?
86.
Just put an X to it. It's okay. That's not in the first mile for sure. That's more of a calculus-y type one.
What about 83?
83.
That was also part of the homework.
Was that one of those rectangle ones too? Oh, no. Oh yeah, you can put a cross through 83 and 86. It's really cool for calculus, and we might go over it like next week when we come back, but let's not stress about it for tomorrow. And the reason why I'm saying that is because tomorrow I told you guys I was going to give you a topics list, right? Oh yeah, hey, I had them ready, but no, it's okay. Main topics for the quiz. I'm calling it a quiz because it's not a full test, but in your grade for a little bit, it's going to look like the only one because it is the only one. And so we have the full chapter 1. It's only on sections 1.1 to 1.5. You guys can take a picture of it. I don't mind. Or you can write it down. But these kind of give you places in your notes to go reference, to go back, to look at. Now, honors is just going to have like a one piece of paper, front, back, 10 questions, one bonus. Here we go. Every single problem is worth like 5 points. This is like a half test. You guys can be rough if every single problem is worth like basically 10% of the test. Right? So instead, I gave you a longer one. So it's going to look more like a test as far as how many questions. I think I gave you 20 questions. Yeah.
Multiple choice?
17 of them are multiple choice. Do you want me to give you some more specific details? So we have these topics that you should probably go back and review. The symmetry, I would add in even and odd. I would add in even and odd. And the things that went over in section 1.5, like average rate, might be a good idea. But let me give you some more specifics. Cool? Oh, that's already up there. That's good. Function notation, guys, when I say function notation, I mean specifically like f of x plus 2 or f of 5, plugging in and plugging in carefully, such that you're not killing anything, right? I didn't put it up there. Oh, I did. Slope formula. But remember, that could also be called average rate. There is one factoring problem. There is one factoring problem. It does have a number in front. There are some things about what quadrant would a certain point fall. That's kind of like section 1.1.1.2, but most of you guys are doing really well on that. Intercepts and symmetry are up there. When testing for symmetry, you guys can use the test points, but also be ready for even odd. Standard form of an equation is just plugging in, slope between points. Ooh, parallel perpendicular. Parallel perpendicular. How to plug into a piecewise. How to plug into a piecewise. Domain. I was doing that out in the field. Domain. And the last is difference quotient and increasing decreasing. Difference quotient and increasing decreasing. You guys have a chapter 1 review that has practice problems on all of these. If you want to practice, problems are there. I'm here today during lunch and after school. Sorry about the fire drill, guys. I have no clue.